Okay, it's time for my absolute favorite lesson in the beginning of Algebra 2 at least, and it's factoring. So factoring quadratic expressions, it's going to seem like a bit of a puzzle, almost like a game, and some of you will pick up on it extremely quickly, and some of you it's going to take a little more perseverance. So I just want you to stick with it. It's a huge concept in algebraic manipulation that's going to kind of follow you through the rest of your career of doing math. And there is a point to it, I promise you. So just kind of get your brain wrapped around the fact that you might have to make some guesses, checks, and revisions before you stumble upon the right answer. And then the more perseverance you show, the easier it's going to be in the long run. So the idea is factoring is the reverse of what we call distribution of binomials or foiling. So let's remember what it even stood for. It was an acronym, and it was a way of having an Algebra 1 student remember to distribute all of the components to each other. So the F part of foiling represented what happens when you multiply the first two terms together in each binomial. So x times x was 2x squared. And then the O stood for outside or outer. So x times negative 5 is negative 5x. And then I stood for the inner terms multiplied together. So that was positive 6x. And then L stood for the last terms multiplied together, which is negative 15. So your Algebra 1 teacher would then say, okay, that's great, but you have some like terms in the middle. So the simplified polynomial answer would be plus 1x in the middle here, minus 15. So what we're going to do in Algebra 2 is we are going to start with the polynomial version, and your job is to rewrite it as a product of two polynomials, mostly binomials. So basically everything we just did in reverse, which is going to be fun, right? So let's talk about what that looks like. The first few we're going to do are going to be considered the easier problems. We'll talk about why in a little minute, but just think of what happens. This is the answer to a foiling problem, right? So this term right here is what happens when we multiply the first terms together. And then this middle term is what happens when the outside and the inside arches, I call them, are added together. And then this last term here is what happens when I multiply the last two terms together. It's possible you guys called these diamonds back in Algebra 1. We're going to get away from the thought of thinking of everything as a diamond. You'll see why in a minute. So let's talk about my first two terms. When I multiply these first two terms together, they have to give me a product of x squared. Well, if I think about all my possible combinations without involving fractions, there's only one way to get that, and that would be x times x. So for a moment, I want you to ignore the negative 12x in the middle and jump to the end of the problem. My last two terms, when I multiply them together, have to give me a product of negative 28. So I think about what that means for my signs. Two numbers multiplied together give me a negative 28. That means my signs have to be one positive and one negative. That's the only way to get a negative product. But 28 has a lot of factors. So like 28 and 1, 7 and 4, 14 and 2. There's probably more, but I don't know. So I should have wrote those down. 14 and 2. So if I think about my signs as being 1 plus and 1 minus, and I look at all my number combinations here, the last part of the puzzle is that when I multiply this outside arch and I multiply this inside arch, they have to add up to negative 12x in the middle. So when I think about my number combos, 28 and 1 will not do that, neither will 7 and 4. I think 14 and 2 will do it, but you have to be careful who's negative. And if you're not sure, just throw something down, check it out, see if it works. But let's look. What if I make the 14 the negative and the 2 the positive? On this outside arch, now I have a negative 14x, and on the inside arch, I have a positive 2x, and when I add those two arches together, I get negative 12x. So that is the correct factorization. I know that felt like it took a year to get the right answer. It's going to go so fast. You guys are going to get so good at these. We have to kind of start basic and then kind of keep upping the rigor, and so you want to stay along with me. You don't want to fall behind your classmates, right? Y'all will be factoring before the end of the semester. You're going to be factoring very well. All right. So same acronym that we could use to help us through this problem. The first two terms, when multiplied together, have to give us x squared, so those have to be x and x. There's no other way for that to happen with integers. The last numbers multiplied together have to give us positive 4. So as far as signs go, they can either be two pluses or they can be two negatives. But if I look at the problem, I notice the inside arches have to add up to a positive 5. So I don't think it makes any sense to consider negative negative as an option. So I know the signs are plus plus. I'm going to go ahead and write those down. So when I think about my numbers that will multiply to give me 4 and 1, or so 4 and 1 and 2 and 2. So again, remember the last part of the puzzle is to come back to the middle and say, okay, when I add up my arches, which these arches are multiplications, they have to add up to 5. So that's going to have to be 4 and 1. Because that's a 1x, that's a 4x, and when I add those together, I get 5x. So here is my factorization. All right, next problem. My baby in the background. All right, F, O plus I, and then L. So my first two terms multiplied together are x and x. Now, if you're watching this video as a review, by the way, you probably want to skip this beginning part because you probably are good at this type of factoring. Maybe you need more help with when there's prime and non-prime coefficients instead of 1. Maybe skip ahead to that. All right, plus, plus, plus everywhere. So that means my factors are going to have plus signs. And then my numbers that multiplied in 14 are 7 and 2 and 14 and 1. So when I look at my arches needing to add up to 9x, I think 7 and 2 is the way to go. And I would confirm that they work with the arches here. I know this seems a little tedious because you're like, I totally know it works. You're going to be surprised how many things that totally work in your head. But if you write them down, sometimes you like negated a sign wrong, or just trust me, do the arches. All right, so there's our answer. This is the correct factorization. And one more. Now, 80 is kind of annoying because 80 has a lot of factors. So I try to think about the most obvious ones to me, which to me they might not be as obvious as they are to you, or vice versa, but 80 is like 16 and 5, 8 and 10, but we haven't even talked about signs yet. Remember, I have to multiply to a negative 80, so it's going to be 1 positive and 1 negative sign. When I think about, there's other factors, by the way, but I'm going to stop because I already see the answer. What if I did a positive 10 and a negative 8? That becomes negative 8x on the outside arch and positive 10x on the inside arch, which add up to 2x in the middle, which is what I needed. So here's my factorization. Very good. So you thought that was easy? Cool. If you didn't think that was easy, just keep practicing that level for a while. Let's move on. These are going to be more difficult because this first term is not going to be a 1x squared, but the process is going to be exactly the same. I know there's some teachers out there who teach these all differently. They do something called slide and divide, and they do other tricks. That's great if you're like really, really, really stuck, but I want you to be able to have really good number sense and move through these very quickly. I think slide and divide kind of hinders that. So if you're coming from another teacher and they taught you slide and divide, you might consider ignoring that. No offense to the other teachers. All right, so this time, my first terms, when multiplied together, have to give me a product of 3x squared. So the good news is 3 is prime, so if I don't want to include any sort of fractions, there's only one way to get 3x squared, and that would be taking a 3x multiplied by an x. Ignore the middle completely for a minute. Let's figure out what about multiplying on the back ends here to give me positive 10. Let's talk about signs. So positive 10 as a product either has to have a plus plus or a minus minus for signs. If I kind of look into the middle of the problem, I notice the middle terms have to add, the arches have to add up to negative 17. So I think we have to go with the negative negative signs. So I erased too much. So since they're both going to be negatives, I'm just going to throw down a negative and a negative. Let's talk about numbers. 10 and 1, 5 and 2. Like, I don't know, because a lot of kids freak out here and they go, wait a minute, nothing's going to add up to 17, Abruzzo, like you messed up. I didn't, because let's look. Here's what makes this more exciting. This first arch, whatever gets placed in this last blank is going to get multiplied by that 3. It's like an amplifier. So you have to remember that. And if that's too much for your brain to handle right now, like it's really early in the morning for me and I'm super tired, so maybe I don't think real hard and I just throw down a guess. Now, as you get better at these, you'll learn what is a good guess and what is an inappropriate guess. We don't typically like to choose the numbers that are really far extreme away from each other. So like 10 and 1 are really far away from each other and they produce really large values in the middle. Sometimes you want that and sometimes you don't. So I'm going to go with 5 and 2 and I don't know, let's try. And this is what happens when you mess up. Let me show you. It's really not the end of the world. The outside arch is negative 6x. The inside arch is negative 5x. That does not add up to negative 17. So does that mean I throw 5 and 2 out? No. Maybe I consider switching them. what I put here. So obviously things change, right? So this is negative 15x. Whoops, that's a 5. And then a negative 2x. Those do add up to negative 17. So see, a little bit of perseverance, and we ended up with the right factorization. As you get better at these, you can do more mental math and anticipate, like, oh, I should put the 5 with the 3 because that gives me a 15 and then a 2. And it'll come to you really quick. My son sees a bug. He's freaking out. Let me take care of that bug just a minute. We're back. Let's try another one of these more difficult problems. So same issue. We're going to have a 2x and a 1x in my first terms, which is going to amplify or multiply whatever is on this outside arch by a 2. So we have to keep that in mind. Now, good news, everything here is a plus sign, so that means my 2 signs and my factors have to be plus. And even better news, 3 is prime, so the only option is a 3 and a 1. The only trick is, where do I put the 3 and where do I put the 1? Thank you, baby. So let's think about this, guys. If I put the 3 here, that's going to become a 6. That looks exciting because watch this. This is a 6x, and this is a 1x, and these add up to 7x in the middle, which is exactly what I wanted. Look at that. So prime numbers are good things when you're trying to factor, right? So of course it would make sense if I give you something that's not prime. All right, so my first 2 terms. Problem already. 8x squared, there's more than one way to get 8x squared. You could do 8x and 1x. You could do 4x and 2x. Good news is those are the only options. So now we have to make a decision. And it's essentially a guess, but I'm going to make an appropriate guess based on my experience. I know that when I put extreme number cases in my factors, like 8 and 1, that's going to produce really large numbers in the middle. I don't know if I want really large numbers in the middle. I might. I don't think I do. But we'll find out. What's the worst that happens? I make a guess and I go through some work and I go, yeah, that didn't work. So then I go back to my next guess. I'm going to go with 4x and 2x. So then my last numbers, and the plus signs on everybody, I notice. So let's take care of the signs. My last numbers have to multiply to give me a 9. So my options are 9 and 1 or 3 and 3. Again, extreme number cases generally aren't good. So I'm going to avoid them. I'm going to go with 3 and 3. And I also like to go with 3 and 3 because there's no way I could reverse the order of 3 and 3 and get a different answer. So if for some reason I eliminate the 3 and 3, then I've eliminated a lot of options actually. Let's see what happens. That is a 12x on the outside arch and a 6x in the middle. And when I add those together, 18x. We guessed well. It's educated guessing, right? All right, number 9. Oh man, 18. It's like one of the worst numbers you can get for a lead coefficient. Because 18 is 9x and 2x, 6x and 3x, 18x and 1x. So from my previous experience, I'm going to say forget the 18 and 1. I think that's way too extreme. Now I just have to, I literally have to just make a guess. So I don't know. And actually every year I do this problem, I kind of just play dumb and let the kids make guesses because I don't want to have them think like I'm a silly pants for guessing the wrong one. But if I do a little bit of mental math here, all right. Well, most kids end up picking the 6x and 3x. So I'm going to show you what happens when we do this. Okay. Negative 14 means we're going to have 1 plus and 1 minus sign. And the options are 14 and 1 or 7 and 2. So hopefully you can kind of anticipate 14 and 1 being too extreme. Let's go with 7 and 2. Now here's another place where I could use my smarts and make an appropriate guess and don't even bother with a guess that doesn't make sense. It would not make sense to put a 2 right here. Because if I put a 2 right here, notice that this factor has a common factor of 2. 6 and 2 can both be divided by 2, which means I would have been able to factor out the 2 of the whole problem. But look at this original problem, guys. There's not a common factor of 2 in the problem. So a common factor can't just like magically crop up in the middle of your problem. So I'm going to use 7 and 2. I'm going to have to put the 2 over here and the 7 here. And my co-teacher gave me a really quick, cool trick. They said, before you write down the positives and negatives, just come up with the numbers and then decide if you want which one to be positive and which one to be negative. So this number is a 12x and this is a 21x. And look at that. They would add up to positive 9 if the 12 was negative. So let's go ahead and make the 12 negative by making the 2 the negative. So, up until I taught with my wonderful co-teacher for years, I never thought of that trick because like I always just kind of muscled through the problems and then I basically used pencil a lot and I kept erasing. But I thought that was kind of a neat trick. So if you're not sure where the signs go, wait to the end to put the signs down. All right. But speaking of common factors, we should talk about common factors. Before you even pretend you want to factor the expression using reverse foiling method, you should look for what's called a common factor. A common factor is something that both of the terms can be divided by. And they could be numbers, variables, combo, whatever. And they could also be negatives, so remember that. So 8t squared minus 4t. Those are both divisible by 4, so let's take out a 4. And they also have a t in common. So factoring out, a lot of kids refer to this as undistributing. So think about what happens when you distribute something. That's because you are multiplying it in, right? So if you're going to factor out, then we're going to divide it. So look what happens when you divide both of these by 4t. We are left with 2, and then we still have a t minus. Now 4t divided by itself, they do cancel, but they still remain as a factor of 1. Because if you were to redistribute the 4t, you got to get back to that same problem. All right, next one. Look for common factors. There is not a common variable here, but 3, 6, and 24 are all divisible by 3. So let's see what happens when you are left with after you divide by 3. So I'm left with x squared plus 2x minus 8. And you think we're done, right? We're not. Because that thing that I left in red is factorable. So my first terms have to give me x squared, meaning they are x and x. My last terms have to give me negative 8. So I have 1 plus and 1 minus. 8 can be 8 and 1, 4 and 2. I think 4 and 2 is the way to go, because if we do positive 4 and negative 2, don't those add up to positive 2? If I figure out the Archies? Yep. So the complete factorization is what we call this, is this guy right here. A lot of kids try to muscle through that question, and they try to do reverse foiling here, and they'll get something like this. They'll get 3x plus 12 times x minus 2, or they'll get x plus 4 times 3x minus 6, and then they'll complain to me on a test. They'll say, I totally factored it and you counted it wrong, and what's wrong? The issue is they're not completely factored, because look at these, either one of these factors. Do you see the common factor of 3 that they never took out of the problem? So if you have to take it out at some point, it's in your best interest to take it out at the beginning of the problem so your math is a little easier. All right, here we have a common factor of 5 that we could take out. So if I think about what's left when I divide by 5, I get x squared minus 4. Which brings us to my favorite factoring pattern, the difference of two squares. This is really easy to factor once you pick up on it. X squared minus 4 is a reverse foiling question. The only weird part is there's nothing in the middle term. So essentially what happens is my factors are twins of each other, except one is going to be a positive and one's going to be a negative, and that's going to produce additive inverses, we call them, on the arches, who end up canceling each other out. So if you think about numbers that multiply to 4, I'm thinking 2 and 2, and if one was positive and one was negative, wouldn't that middle set of arches cancel out to nothing? So this, my friends, is the complete factorization of that expression. All right, so that was a special pattern. It's called the difference of two squares, and we refer to them in class sometimes as the good twin, evil twin. It's not really a nice thing to say, but so the idea is if they're both square rootable things, the way they factor is to a good twin version of it, which is just the square root of each of them, and then an evil twin version of it, which is the same, except this sign is going to have to be the opposite. So x squared minus 9, remember it's the same thing as x squared plus nothing minus 9. So we're going to need the good twin of x plus 3 and the evil twin of x minus 3. These next two patterns are a little harder for us to pick up on. I'm going to move my camera out of the way. They're a little more difficult for us to pick up on because a lot of kids don't recognize them. But here's what I do. If you notice, the first and last parts of your polynomial are perfect squares. So your perfect squares are 1, 4, 9, 16, 25. There's a good chance that you should be looking at this pattern or this pattern. So like for instance here, when I have 4x squared, blah, 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 plus 9. I notice 4 and 9 they were both perfect squares. So while 4 and 9 do have multiple factor options, I'm kind of leaning towards the square root of their factors, right? So instead of 4 and 1, I'm going to go with 2x and 2x. And then instead of 9 and 1 for the 9s, I'm going to try 3 and 3. And the reason this works out beautifully is because your arches are the same. So plus 6x plus another 6x is how you're going to get that plus 12x in the middle. So the way the pattern works as far as recognition, if you take the square root of the first number and the square root of the last number, and you multiply them together, so that's one arch, and then you have to double it, right? Because there's two arches. That's how the pattern works. So as far as memorization of patterns, I don't think it's worth your energy for this class at least. What I would like you to think about though is if you recognize, ooh, I have perfect squares at the beginning and end of my polynomial, then I want you to think about taking the square root factors of them instead of anything else, okay? So same thing here. I notice these are both perfect squares at the beginning and end of the polynomial. So even though I have multiple factor options, I'm going to go with the square root factors. So 5x and 2. And if you look at the signs, it would only work out if you had two negatives, right? So that's negative 10 plus another negative 10 on the arches, which is how we get the negative 20. Notice the pattern. They write them as x plus or a plus b squared or a minus b squared. That is a shorthand way of saying the exact same thing. So like I said, I'm not real big on memorizing like patterns because why? So I have enough to remember. I get like 150 kids' names to remember every year, and then all the old kids will come back and I don't remember their names anymore. All right, so this is probably the beginning of your homework. I want you to make sure that you look for common factors before you continue to factor through the problem. For instance, number 1 here, you're going to look for a common factor. I'm not going to say that's where you end the problem all the time, but you do need to look for a common factor. 2, 3, 4, those should all be pretty easy factoring questions. So if you're kind of like feeling really unsure of what you're doing, I want you to just start with the easy ones for now, and they continue to be easy all the way until you get to, watch out for number 10. That's one of those weird difference of two squares. So it's either follow the pattern, or you could rewrite it like this, right? 11 is where it starts to get kind of weird because you're going to have a common factor plus you're going to have more factoring after that. So have fun with that one. And then same thing on 13, you're going to have some fun with factoring, two levels of factoring, right? 18, that's where it starts to get exciting. So if you're trying to practice the type of reverse foiling where you have that multiplier that affects your arches, you're going to have to watch out for those. And then they get really exciting as you go through. So practice makes perfect on these guys. Okay, lots and lots of practice. Perseverance. Yes, lots of alliteration in there.